with that, I'd like to introduce our next speaker, Derek Nesset from Huawei. He's presenting on optical access development in ITU. Quite important issue since not every PON standard is a standard. With that, I'd like to hand it over to you, Derek.
Thank you, Bernd. Thank you also for the organizers of this event. It's a great pleasure to speak to you today. Okay, so as Bernd says, yeah, I'm working for Huawei. And this presentation, I'm really representing Frank Effenberger, who's the Question 2 Rapporteur and Study Group 15 of the ITU-T. So this is where all the kind of optical access standards are defined in ITU, and he couldn't make it this week. It's not a Huawei view, it's really just a kind of overview of the activity which is going on in ITU. And he's given me a lot of material, so I'm going to have to go pretty quick. So we've been quite busy with our activities. Okay, here's the first surprise. The font has gone a bit strange there. Okay, hopefully I don't have any blank slides. Okay, so I think we all know here in this community that optical access is really considered the premier broadband solution, which saw a great presentation just now from Roger showing what's happening in the UK with BT's move to full fiber. Mainly, we've seen that for residential services. And as I said, in ITU Question 2, Study Group 15 develops the standards for this technology. And we've seen that move in the market to a well-defined state with very good levels of interoperability and a very big business. You can see this chart from Omdia showing the size of the market today and how it might evolve in the future. So tens of billions of dollars of revenue. This slide is showing, it's kind of an overview of the family of optical access systems. So it's good to see Roger also had a very similar chart, showing the top row. So this top row is what we would call the TDM PON. Oops. The TDM PON type of system, so time division multiplexing. So I think everyone's familiar with GPON. It's the most successful standard that we had out of ITU to date. And actually, I think of all the standards bodies. And then we moved into the 10G-PON era with XG-PON, and the most recent standard that we've completed is the 50G-PON standard. And I'll go into these in a bit more detail in a minute. And now one of the big activities we're working on is the very high-speed PON, looking like it's going to be a 200G capacity type of system. The other things that we've worked on, so the second row here is the kind of multi-wavelength systems. So the 10G-PON per channel version, which you may have known as NG-PON2, TWDM type of system, so time and wavelength division multiplexing. And that's now evolving to a 50G per channel line rate as well. That's an ongoing activity at the moment in Question 2. And some people might not know, but we also work on point-to-point systems, so single fiber BiDi systems. We started with 1G quite some time ago, but actually there's been a recent uptick in this activity. So extending that from 10 to 25 and 50, and more recently 100 point-to-point fiber systems. A lot of this done kind of in parallel and in conjunction with work which is going on, complementary work in IEEE. So trying to make sure we don't duplicate. There's not actually, we don't work against each other, should we say, in this space. Everything's quite complementary. And then finally, we also have a WDM PON system. So this is where you don't have a power splitter in the fiber plant. You have a wavelength splitter in the network. And we've defined a 20-channel, 25G per wavelength system for WDM PON. And in terms of the recent major work areas, so I'm going to go into these in more detail, so I'll just quickly review what we've been doing. So there's ongoing maintenance tasks, so we always need to maintain the standards that we have. We always find some little bugs or gotchas in the things that have been defined once people start to implement them. We've been working on the higher speed PON system, so that's the 50G line rate, so 50G TDM PON, and then also the TWDM PON. We've also been looking at new applications for PON, so beyond residential. So wireless is one of the major ones, but also some new things, fiber to the grid, and also something which is fine-grained OTN over point to multi-point. I'll introduce that in a minute. And then I think probably the most kind of the dominant activity that consumes most of the meeting time at the moment is the very high-speed PON activity. So I'll talk about what's going on there. And then we have a new activity on technology roadmap, which is actually a PAN study group 15 activity, which is just underway, and I'll review that as well at the end. So in terms of the maintenance work that we're doing, so you don't really find out how good your standards are until people start to implement, and then you realize that maybe something can be read two ways by different implementers. So we have to go and fix those issues. XG-PON itself was fairly trouble-free. XG-PON was kind of perfected XG-PON, so improved some of those things and streamlined the way things were done. Very little has changed since those days. There's a few notable additions. So we now have multi-rate operation in our systems. So you can have mixed rates, for example, in the upstream. Excuse me. Also with the TWM systems and the WDM-PON, we have multi-wavelength management to deal with. Also, there's been requests for some of the new applications for PON to have higher or enhanced security. And also one thing we've had to do as we up the line rates is improve our forward error correction capability. So with, for example, LDPC and 50G PON. And some of these complexities that we've introduced, of course, some kind of dysfunctional corner cases where implementers have problems. So we've worked to fix those. And one of the ones highlighted here is where we have the multiple ciphers which were introduced with the 50G PON. And that's been all clarified in the base standards. And there's a supplement we have which kind of describes some of the resolutions there and some of the clarifying activities that we've undertaken. One of the big documents we have within our standards is the OMCI. So this is the management channel that we have for the subscriber equipment, the ONU. It's a huge document. And this is basically dealing with all the features and things that you need to manage on the ONUs. We're always adding new features to that, and revisions are basically continual for that document, and updates continually coming. And I think certainly in this forum, you'll be well aware of OMCI. It's really the basis of the interoperability work that you do in BBF. And these are documents which you'll be much more familiar than me, in terms of how you look at OMCI for your conformance and interop work, the work you're doing on netconf yang, things like that. Actually, OMCI is now being leveraged in kind of an adjacent space. So there's also activity in ITU. It's not in question 2, it's in question 3 of study group 15 on fiber to the room. So they're extending OMCI to a kind of home network management domain. So that's another place where we've reused all the hard work which has gone on in defining OMCI in a kind of new market space. So high-speed PON, or for short, the 50G PON at the moment. So things that have been going on there, 50G upstream has been a key focus of our study there, and also I'll talk about the deprecation of 12.5G in that recommendation. So in the beginning, we thought that maybe the 25G upstream would be, let's say, the majority solution, the mainstream. It kind of matches the 2-to-1 asymmetry that we have with GPON, and that's served us well so far. And we heard from OpenReach just a moment ago how GPON could continue to serve them quite well for long into the future. But actually, it's turned out that for some of the new applications for 50G PON, and certainly the early applications, it seems like residential is not the primary focus. It will be business and maybe other high-end applications. And that's really brought forward the kind of operator, network operator draw, service provider draw for the symmetric, so the 50G upstream in this recommendation. So the issues with 50G upstream is the receiver. It's quite challenging to meet the receiver sensitivity that you need. and operators strongly favor what we call a common ONU approach. So basically, we have a single ONU type out in the field from an optical point of view. And then when you want to change the optical budget, you just change the optics on the OLT side. And I think the issue that we have in question 2 is there's basically a difference of opinion or a different analysis about the best way to distribute, let's say, the difficulty of this between the OLT side and the ONU side. And we've closed the gap quite well to a 1 dB gap, but we realize that's not it's not ideal that we have 2 solutions in the market, and we're looking to try and merge those, and hopefully that will be resolved soon, and we'll have a kind of unified solution defined. At the beginning of 50G-PON, we thought that maybe 12.5G was an interesting line rate. Maybe it could provide a very cost-effective upstream rate for certain users. But actually, it's turned out that with the evolution of 25G technology, you can pretty much do the same, offer the 25G rate for almost the same cost as you could the 12.5G. So service providers are not really interested in the 25G anymore, so that is now being deprecated within the standard. So we'll just have 25G and 50G upstream rates. In terms of the TWDM-PON, so this is the 50G extension of what was the NG-PON2, the 10G line rates. So if you think of NG-PON2 as kind of the multi-wavelength version of XG-PON, then 50G TWDM-PON is the sort of multi-wavelength analog of 50G-PON. And the issue we have there is dispersion in the fiber. This will drive us to work in the O band, so the 1300 nanometer region, where actually a lot of our systems are already operating. So there's very limited spectrum, especially to if you want to offer multiple wavelengths. And in terms of technology, most of the tunable components that are out there in the market are for kind of long-haul metro networks, and they're operating in the C band, so that would kind of push you in that direction. And then also service providers who are deploying NG-PON2, they're already working in the C band, and what they would like to do is kind of upgrade channel by channel. So they'd like to reuse the muxes which they've already deployed in their network. So that also pushes us into the operation in the C band. And really using intensity modulation and direct detections, almost impossible, let's say, in the C band with conventional techniques. And that's kind of driven a move to look at coherent as a technology option for this multi-wavelength 50G-PON, 50G per channel technology. So that's really kind of the front runner at the moment in terms of technology. It's the one which is being studied at the current time as a kind of straw man for people to analyze. I mean, we're looking at maybe a single polarization, so simplifying the coherent a little bit from what you would see in long haul. And then we also have the advantage that we need tunability in TWDM, and the coherent receiver is inherently tunable. You can tune the local oscillator, so you don't need a tunable filter. And you can tune over just a small range of 4 channels just using temperature. So that's, from a technology point of view, that's quite feasible. Okay, let's switch gears a little bit. So now we'll talk about some of the new applications which have been coming up in question 2. And what I've been talking about previously is standards, so recommendations within the ITU context. All these things are what we call supplements, so they're kind of supplementary information to our standards. They're not defining standards, they're just kind of analyzing, let's say, an application and capturing the requirements. And so we get a kind of common view of what's needed, and to kind of guide the industry and maybe guide future standardization. So the first one is the wireless domain. So we have 3 supplements there. The first one, this one is dealing with wireless front haul. So seeing how PON, this is supplement 66, and all of these I provided references for at the end of the presentation. So this is describing how you could use PON as a wireless front haul technology, and cataloging the technical requirements that you have there. The next one is dealing with what you need on the OLT side. This is supplement 71 to enable the cooperative DBA. So this is the dynamic bandwidth allocation that you have in TDM-PON. And this is where essentially the wireless, or the RAN equipment is able to talk to the PON equipment and basically share scheduling information and inform the PON that some capacity needs to be enabled for so let's say a user's handset or something like that. And you can reduce the latency within the system by the two systems talking to each other. So there's ORAN has already defined their CTI, I think, cooperative transport interface. And this is kind of the ITU looking at what's needed to make that happen. And then finally, supplement 75 is dealing with small cell backhaul. And once again, looking at how PON can be used in that application and the typical requirements for that. Then we have something which we're just calling here just special services. It's just maybe just kind of, let's say, just left field kind of applications that we're starting to see for PON, so things which are maybe slightly outside what we would normally see. So the first one, supplement 82, is dealing with what was called enhanced OLT. So I should say all this is kind of driven by the user community. So these are things which they are interested in and want to see studied within question 2. So we have this supplement which is talking about compute and storage resources which are put at the OLT side. There's numerous, I mean, if you look at the supplement, there's numerous applications which are captured for this, including things like edge caching and things like this, or AI or other kind of applications that you might put at the edge of the network for adding some, providing some value-added services and gaining more revenue. Supplement 85, the middle one there, is talking about fine-grain OTN, or carrying ODU traffic over a point-to-multipoint network. So OTN is typically a point-to-point system, which is defined in other questions within study group 15. And this is where end users are wanting, or service providers are wanting to carry old, let's say SDH type traffic, so very low bit rate down to something like 10 megs, but in an efficient way. So using the very high capacity that you have in PON today to aggregate those systems. So don't use point-to-point fiber anymore, use a point-to-multipoint PON topology, and be able to carry those clients in an efficient way over a more modern infrastructure, so OTN-based infrastructure. And then the final one is fiber to the grid. So this is the power grid here. And this is where power network operators, they're having to have much more intelligent systems in future to handle the kind of renewable energy generation sources of solar and wind and all, these kind of new technologies, which are very different to the technologies that we saw of old and needs a lot more management and control and data to operate it. So that's looking at that application for PON. Okay, so moving back to the kind of more of our bread and butter in question 2, so looking at the evolution of PON to higher capacity. So after high-speed PON, we very innovatively defined the next one as very high-speed PON. And here, at the moment, this is a supplement. So we're just gathering kind of straw man baseline requirements coming from network operators. And the first thing which they've defined is they don't want to talk about line rates anymore. So in the previous generations, we were 50G was a line rate, 10G was a line rate. Now they want to talk about information capacity. So the current target is 200G for this system. So 4 times the capacity of or more than 4 times capacity of the previous generation of system. And they're anticipating needing 100G peak rates from their clients. If we consider the FEC overhead is going to be about the same, 20% that we see today in 50G PON, then that means that we need a line speed of 240 gigs. So that's what we're doing so the next step is we get the requirements, and now we're doing a kind of a technology landscape. So what technologies are candidates for such a system, and then, okay, what are their pros and cons, and what performance can really be expected. So that's the work that we're undertaking. And I should note at the bottom that these are just these are, I guess, iterative requirements, so they will probably evolve as we continue the study. But this is the kind of baseline we're working with at the moment. I probably won't go into the detail of this too much on this slide. I think what it's trying to say is that basically each generation of PON, we need some kind of technology development as we go through there's always something new that we need to add to enable the higher speed. And really, with very high speed PON, the question we're trying to answer is, okay, what technology evolution do we need to enable this 200G capacity? And in the background, the one constant that we have is that the network operators, the likes of OpenReach that we heard before, they've deployed. They spent a lot of money and a lot of time and effort in deploying their fiber infrastructure. They want to keep just using that as long as possible into the future. So that is fixed in terms of we have to deal with those lost budgets, we have to deal with those reaches, and we also have to deal with coexisting with the legacy PON systems which have been deployed already. So there could be GPON, XGS-PON, 50G-PON already in the network that we need to coexist with. So all PON systems that we've defined to date have been using intensity modulation and direct detection with non-return to zero on-off keying as the line code. And we're now kind of approaching the limits of that approach. And these charts are just simply showing you reach on the vertical axis and wavelength, assuming different zero dispersion wavelengths in the fiber, because those things are not fixed. And really just showing you they have a very limited wavelength range over which you can operate. You're really limited to the very close to the dispersion zero wavelength of fiber around 1310 and maybe 10 or 20 nanometers either side. So right where GPON sits today. And we're also limited in the line rate that we can work out, with the baud rate that we can operate. So we're probably limited to around 120G in these systems, which means we're probably going to have to take the Ethernet approach of having parallel optics to reach these higher speeds. So 2 lanes of 120G will enable a 200G capacity system. These are the kind of studies which we are doing. So this is actually what I spend a lot of my time doing. So we look at the dispersion in the fiber, cumulative dispersion, picoseconds per nanometer, and our kind of receiver sensitivity penalty as a function of that. And then we can then map that onto wavelengths which are available in the fiber. And we can look at different modulation techniques and also different equalizer technologies. And we can try and decide which is the best technology approach and what is really feasible, what wavelengths we can actually operate. So this is the kind of detailed studies that we're undertaking right now in question 2. As an alternative to IMDD, so if you're ever following some of the work which happens in IEEE on datacom transmission, they're always asking the question, okay, is it IMDD or is it coherent? And that people are always predicting that coherent could be the answer to the next generation, and they always find that actually IMDD can they find a way of making it work for each generation of datacom. We're kind of at that same point where we're saying, okay, is it IMDD or is it coherent for VHSP? And certainly from a technical point of view, coherent can basically tick all the boxes. It can meet all the requirements in terms of reach, loss budget, coexistence. It can coexist with any PON. You can work at any wavelength that you like and over any generation of fibers. So old fibers that have high polarization mode dispersion, you can handle that. The big question is in terms of the economics of coherent. And we're looking at what this picture is showing here is different complexities of coherent receivers. So this is a full coherent receiver, and then these are simplified versions. This is just coming from the research literature. We're basically looking at, okay, what's the, what are the advantages and trade-offs of these different techniques, and can we actually make coherent low enough cost for the, the typical applications we have for optical access. We also look at, the state of the art. Here we're looking at receiver sensitivity. It's really, drives what link budget that we can achieve with each generation of PON. And we look at that sensitivity as a function of speed and what's been published in the literature and products which are out there already today. And you can see there's a fairly clear dividing line between the red dots, which are coherent, and the kind of bluish dots or squares and circles, which are intensity modulation, direct detection. So we can see the kind of solution space that each one can work in. In general, the IMDD is lower receiver sensitivity at the high speeds, which means you'll need to launch more power. So there's always some trade-off that you have to make. And then obviously coherent, we already know that does very well in long haul and achieves very good sensitivities at very high speeds. So I shall whiz through this. So this is VHSP outlooks. I can see Bernd's getting nervous. Yeah, so basically VHSP, it's a long-range project. We're looking at 2030 as the kind of application horizon, so 2030 plus. It's a 250G line rate type of system, and we need to run over the existing legacy fiber, coexist with previous generations. IMDD is nearing its limits. It is expected to be the lower cost solution, but it does have some technical challenges. Coherent is technically safe option, but there are many variants, and the economics of that are unclear. And maybe some of the things which are going on in data center and other application spaces might help us in lowering those costs. Really, just quickly, I would just say something about the road mapping activity. So this is something which is going on. It's a PAN study group 15 activity, and it's trying to learn from what's happened in the wireless space, where we have 3G, 4G, 5G, all these kind of generational definitions, and trying to do things, the same thing for optical networks. So this is called, the kind of activity is called International Optical Networks 2030. And this is a PAN study group activity in study group 15. It's being coordinated by question 12. And there's a very synergistic activity already happening in ETSI ISG 5G, and that's already looking at road mapping activity, technology, landscapes, generation definition, all that kind of thing. And I think they'll be downstreaming some of their work from that into ITU.
Thanks a lot, Derek. Excellent overview and update on all these activities.